All right, everyone, we are going to be writing linear equations in the form of y is equal to mx plus b. And exponential equations in the form of y is equal to a times b to the x power. So let's get started. We got to determine whether each of these situations are linear or exponential. So for number one, Jacqueline's earnings M are a function of the number of lawns N she mows at a rate of $12 per lawn. Write a function of how much Jacqueline earns mowing lawns. So if Jacqueline mows one lawn, she will earn $12. If she mows two lawns, she will earn $24. If Jacqueline mows three lawns, she will earn $36. So the amount that she's earning, we are adding $12 to her amount after she mows her next lawn. So since we're adding the same number over every time, this is linear. And so we have y is equal to what we're adding each time, which is 12, times x. And then she started with $0 when she first started mowing lawns, so plus 0. Or if you just wanted to write it as y is equal to 12x, that would be okay as well. So number two, an investment of $5,000 doubles in value every decade. We want to write a function of how much the investment is worth after every decade. Well, since we're doubling, that means we're multiplying by 2 every decade. That would be an exponential function. The amount you start with is your A. We started with $5,000. And then B is going to be how much we're multiplying by every time, which since we're doubling, we're going to multiply by 2, and then that's raised to the x power. This is your correct equation. Number three, in 1971, there were 294,105 females, and that number has tripled each year. Write a function of how many females there are each year. Since we're tripling, that means we're multiplying by 3 every time. That means this is exponential. So we started with 294,105. So that's your A value in your exponential function. And we're multiplying by 3 every year, so times 3 to the x power. Number 4, the water level of a river is 34 feet. So we start at 34 feet, and then it's receding. What that means is it's decreasing, the water level's decreasing at a rate of 0.5 feet per day. So what that means is that on day 1, we're at 34 feet, but then the next day, we're at 33.5 feet. And then the next day, we're just at 33 feet. So every day we're subtracting 0.5 or adding a negative 0.5 over and over. That means that this is linear. And so what you're adding each time is your slope. So y is equal to, I'm adding a negative 0.5. So I'm going to have a negative 0.5 times x. And your b is where you start, which is 34. So this is your correct equation. Number 5, an art gallery already has 40 visitors, but with new updates made to the exhibits, the number of visitors triples every month. So what this means is that this is an exponential function because we're multiplying by 3 every month. Your A is what you started with. We started with 40 visitors. And your B is what we're multiplying by every month, which is 3, and then that's going to be raised to the x power. All right, number 6. Seth's father is thinking of buying his son a 6-month movie pass for $40. With a pass, matinees cost $1. So what this means is that Seth is going to start with $40. When he sees a matinee, then he's going to end up with $39 left. And the next matinee, he's going to end up with $38 left, and so forth. So we're subtracting 1 every time or adding a -1 every time. And since we're adding the same number over and over, that's a linear function. So we're going to write our equation y is equal to mx plus b form, where m is what we're adding each time. So y is equal to, we're adding a -1 each time. And b is your y-intercept, or where we start, which is 40. So that is your correct equation. Number 7, for babysitting, Nicole charges a flat fee of $3 plus $5 per hour. So what that means is that she gets the $3, and then every hour she's going to be gaining $5 more. So we're adding $5 more every time. So this is linear. What you're adding each time is your slope. We're adding $5 every hour. And we started off with $3 as our flat fee. So this is your correct equation. Number 8, there are 128 teams entered in a basketball tournament. Half of the teams are eliminated each round. So what this means is that I start with 128 teams, and after round 1, I'm now down to 64 teams. After round 2, I'm down to 32 teams. So what's happening each time is I'm multiplying the number of teams by 1/2. So since I'm multiplying by the same number over and over, this is exponential. Your A is what you start with. So I started with 128 teams. Your B is how much we're multiplying by each time. We're multiplying by a 1/2 each time, and then that's raised to the x power. Our last question, a plumber charges $25 for a service call plus $50 per hour of service. So he or she has the $25, and then every hour we're adding $50 on. So this is linear because we're adding the same number over and over. Your m in your linear equation is what you're adding on each time. We're adding $50 every hour, and we started with $25. So this is what your equation should look like. So in the next video, we're going to be specifically talking about exponential functions, and we're going to be talking about exponential growth and decay functions, which means our growth rate and our decay rate are going to be dealing with those percentages again, like we've learned how to find in the previous lessons.